With base 10 blocks, children have a concrete way to learn the concept of place value. Teachers can use the blocks to teach addition, subtraction, multiplication, and division. The blocks represent powers of 10. The long is made up of 10 of the small units. A flat is worth 10 longs, or 100 of the units. Before using the blocks for arithmetic, students first need to become familiar with the relationships among them. These second graders need experience exchanging 10 of one block for the next larger one. One way to accomplish this is playing Race for a Flat. Christine explains.
You roll the dice and then you get, like if you got a 10, you would put 10 where the little white ones go. And then you would put, take them all and put them back where all of the white ones are and put a 10 one. And when you get 10 tens, then you have to take 100 and put it on this side. And then the first one to get 100 is the winner.
Several things are important for teachers to observe while the game is being played. For example, how do children figure the total from 2 dice? Do they know the sum or have to count the dots? When they roll 10 or larger, do they count out all units and then exchange, or automatically reach for a long and then some units? One method isn't better than the other, but merely indicates each child's level of understanding.
I'm almost 100. All I need is one word. I'm at 100.
Can you show me which one is the
After they've
unit,
practiced exchanging, children are ready for more advanced instruction. Bonnie checks that these second graders can use the blocks to represent numbers.
Square.
Okay, that would everyone show 37 on your board? Okay, let's put another number on our board. Can you put 204 on your board? Okay. How would I write that number? 204. Mark.
204.
I'd put it. So this is what it would look like. Mm-hmm. And what does the two mean? Let's ask Jennifer what the 2 means.
The number 2 means to have two flat blocks on the board.
And what about the 0?
The 0 means that you have no tens in the tens column.
Okay, and this one here. What does this one mean? Go ahead, Jennifer.
The 4 stands for units.
Okay, and let's
Bonnie
put on a
introduces addition. Working with the blocks makes it possible for children to add with and without regrouping. Here, she asks children to put 56 on their boards, add 55, and combine their blocks to see what they have all together.
Let's add to it this time.
They check with their partners to see if they agree. Bonnie then asks the group what they have on their boards, and the children respond in unison.
Go ahead, Shannon.
111.
Right, 111.
Bonnie then gives the children another problem, this time to add 27 and 35. Mark explains the process.
You need to know if you have 5 and you have a 7 on your board. So you have to take a 5 and a 5, then leave 2 there and change some of these ones in for a 10.
And then what do you have on your board now?
62.
Okay.
Next, Bonnie has the children work on addition problems in pairs. Here, Shannon and Jean add 164 and 257. Shannon uses the blocks, counting and trading, while Jean watches. Jean then records the final answer they agree upon. These fourth graders use the blocks for missing add-in problems, finding out how much to add to a number to get 500. I want you to start with just 27.
Keep this. Look at this.
27. And now the same question is, what blocks would I have to add to the board so that when I did all the exchanges I could, I'd wind up with 5 flats, 500 at the end. So Katie, let me ask you to try this time. Explain again.
Well, I'm gonna add 4 flats, which will be 400, and then I'm gonna add 7 tens and 3 units.
Let's try it and see.
Okay, there are 10 units here, and I can trade them in for another long, and there are 10 longs here, and I can exchange them for.
And Brian said he would have felt a little more comfortable if you counted them.
Yeah.
Did it work? Yeah. It worked. So this worked. You agree with what you did?
Yeah.
Let's just try once more, and this time, Brian or Chris, I'll give one of you a chance to see if you explain. Let's start with 136.
-1.
And the same question: what would you have to add to your board so that when you got through with all the exchanges, you'd wind up with 5 flats? That's 500.
Okay.
So before doing it, actually, Brian, I want you to think about it and see if you can explain it to me by just looking at the blocks, and then you can check your thinking by actually doing it with the blocks.
Well, first of all, I would add three flats,
Okay.
and then I would add 6 longs,
And why 6 longs?
because if I added 4 more of the units, I could get enough for 1 long, and then all 6 and 60 and 40 equal 100,
Okay.
and then I could just exchange the longs in.
Go ahead and do that.
Okay, now I could exchange these 10 longs in for a flat, and have 500.
Okay. So let me.
see
Once
if I
the
can
children show they understand what to do, they're left with a worksheet of similar problems. They say you understand something best when you teach it, because when you teach, you have to make things clear. When children work in pairs, each child gets to be a teacher.
3, 5, 7. 3, 5, 7. Oh, okay. Okay. We don't have all of these. Okay, so that's 10. Put that on. And then 357. Then we could just take.
These students use the blocks and place value mats for learning the process of long division. This time put out 393. And once again, I want you to divide what you got up into 3 equal piles. And this time, Michael, tell me, how much do you have in each pile?
131.
Okay, I'm going to show you how I'm going to write down mathematically what you've just done. I'm going to write it. I then connect what the boys do with the base 10 blocks to the abstract symbolism. I show them 2 different ways to record the division process.
131.
Okay. So 393 divided into 3 equal piles equals 131. Make sense? I'll show you another way to write it. I could put the 393 like this, and then I divide by 3.
Oh, yeah.
Does that look familiar to you?
Yeah.
And so if I take 393 and divide into 3 piles, how much in each pile?
131.
Same 131. And I put that up here. That's how we do it. Now this seems pretty easy. I'm going to give you one that's a little bit trickier. I want you to start by putting 435 out on your boards. Okay, and this time I'd like you to divide. I asked the boys to divide the 435 on their place value mats into 3 groups.
Uh-oh, I'm getting the different answers.
Michael's almost done.
Oops, that's 12. Why? How'd that get up there?
That's in the 5, one of them. That's in the 5.
Well, you just exchanged. We started with 5 there, Michael. You should.
15?
You started with 5 on the board,
Yeah.
and you just exchanged a 10. Do you have the right?
That's right.
Let's see how this works out. So, Michael, what have you got in each pile?
145.
So, John, what have you got in each pile?
145.
145.
When the students are able to manipulate the blocks easily, they're ready to connect their concrete experience to the paper and pencil algorithm. You know how to do it. I want to show you one thing. I'm going to have you do the problem again, and this time I'm going to show you a different way of recording. We're going to let John do it with the blocks right now. Every time John does something, I'm going to write it down. So the first thing John does is divide his flats and then stop. Now watch what I'm going to do. I'm going to record 3 things. I'm going to ask 3 questions. My first question I'm going to ask is, how many do you have in each group?
100.
100. And I'm going to put the 1 in the hundreds place up here. And now my question is, how much did John put up here when he put up 100 in each group altogether?
300.
And so what he put up there, I'm going to write down here. And my last question is, what's left on John's board? What's left on your board?
130.
135. Now, John, to continue, what are you going to do next?
Change the 100 to 10.
Why don't you change the 100 for 10s and then divide the 10s into 3 groups and then stop. And then you can divide the 10s into 3 groups. And then we stop, and I'm going to record 3 things. The first thing I'm saying is, how many 10s did you put in each group?
4.
And my second question is, how many 10s did you put up here altogether? How much did you put up altogether?
12.
And how much is that worth?
110, 120.
So John just put up 120 altogether, and my last question is, what have you got left on your board?
15.
15. Now, back to work. What are you going to do?
Change the 10 into 1s.
Okay. Okay, now I've got 3 questions to ask. My first question is, how many 1s did you put in each group?
5.
And so I record that up here. And my second question is, how much did you put up altogether that time?
15.
And I put that here. And my last question is, how much have you got left on your board?
0.
10.
Make sense?
Yeah.
Think you can do it?
I'm going to divide.
Given
it
another
into
problem,
4
dividing 537 by 4, the boys are on their own. They keep each other on track as they work. And in some instances, they approach the problem differently. For example, Chris knows to multiply 12 times 10 to get 120. Michael needs to count the blocks.
3 times 4 is 12. Just add the 0. 100, 120. 3 times 4 is 12.
How many of the little unit cubes? The base 10 blocks can also introduce decimals to students. Decimals are best taught by building on what children already know about fractions. They learn that decimal notation is a new way to label certain fractions, those with denominators of 10, 100, or other powers of 10. This class of 5th graders first learns how to write tenths and hundredths as decimals. Now is, can you show me on your board 7 100ths by covering up 7 100ths of your flat? And I'm just doing these exercises to get started so I can get to see how much you know. And Russ, how would I write 7 100ths on the board as a decimal fraction?
0.07.
0.07. Suppose I said to you, show me on the board, on your board, 4 100ths. 4 100ths, and I want to see if I can get a volunteer to come up here and write for me 4 100ths in 2 different ways. So Suzanne, come on up and try it. Thanks. Will you show 13 100ths on your board? And so I have 13 100ths. And what I notice, interestingly, as I look around the room, is I see that there have been 2 different ways for it to show. Over here, and I see this at some other tables, Jeannie has built 13 100ths by putting 1 long and 3 units on hers. And Dina has done it by putting out 13 unit cubes. Who can explain why they're both right? Casey?
Because one has a long one that's 10 plus 3 little ones is 13, and 13 little ones is still 13.
Does anybody have another way to explain that? Salma, try and explain it. How come they're both?
If you cut one of these things up in the little units, they would go on these.
So they're both the same. Once the students learn how to represent fractions as decimals, they're ready to compare and order them. The blocks continue to provide a concrete reference. For example, it's difficult for some children to look at the symbols and tell whether 8 tenths is larger than 67 hundredths. The base 10 blocks help develop this understanding. This is a worksheet that gives you an opportunity to put decimals in order, called Ordering Decimals. And there are 5 exercises. On the first 3, on 3 of them, there are 3 decimals. On the others, there are 4 decimals. Your job on this worksheet is to figure out how to write the decimals that I wrote out of order, in order from smallest to largest. Here's how I'd like you to do it. Watching children work gives me a sense of who has a firm grasp of decimals and who needs more experience. Children at various stages of learning work well together. Here, Win has the opportunity to share his knowledge with Suzanne and Zal. When Win explains his thinking, it reaffirms his understanding while helping others.
No, I mean 24 100ths. Okay, now you got it?
Yeah, okay. 24.
Base 10 blocks also help students learn to add, subtract, multiply, and divide with decimals. We all learn the rules for decimals, that you line up the decimal points when you add or subtract, and count them when you multiply, and do something very, very fancy when you divide. We want children to understand, not merely learn rules. Base 10 blocks help build their understanding. 3 over 100. Use your blocks to show 3 tenths and then 12 hundredths. How much would you have all together if you combine them? Win, you want to try it and see?
42 100ths.
42 100ths. And why do you think that?
Because 3 tenths is 3 of these longs, and plus 12 100ths is 1 long, that equals 40. Plus the extra 2 equals 42.
So the answer to 3 tenths and 12 hundredths is how much?
42 100ths.
And how would I write that as a decimal? Tell me that.
Point
Yeah?
42.
Yeah. Okay, thanks. Let's try one more of those. Work with your partner. I'd like the person on the left to build 8 tenths and the person on the right to build 23 hundredths. Then I want you to find out how much you have all together when you combine them.
Because I'm on the left, I get 8.
Figure this one out. Maisha, what do you think the answer is?
103 100ths.
103 hundredths. Suppose I wanted to multiply 3 times 5/100ths. How would you do that with your blocks? Jeannie explains why 3 times 5/100ths is 15/100ths.
Because you take 5 of the unit squares and lay it on your board 3 times, and it equals 1 of the 10 groups plus 5 of the little groups.
And so what's the answer?
15/100.
15/100ths. Thank you very much. Without base 10 blocks, children are often lost in a world of symbols. Teaching them arithmetic by focusing on the concrete materials brings meaning to abstract procedures.